Hello, I had a request to make a video with this. This is for the exam review that we went over earlier today. So I pulled up the Excel file, and first of all, you can see that these are formatted. Well, the column B, we've got these hash marks. That means we don't have enough space. A couple ways you can do that is you can click on this thing right here and make it wider, or you can double click it, and then you can see what's going on. You'll notice the formats. These are formatted, these are unformatted. There's an opportunity to practice putting things into format. There's a few ways to do it. For example, I can right click, go down to Format Cell. This dialog box will come up. I can select the appropriate format, click OK. This one, if I come up right here, you can see where I can format it to a percentage with one little click. Maybe I can add the appropriate amount of uh, decimals in there. Short date, another way that I can format is if I come up and click about right there, I can drop this down. And let's go down to the short date, long date, same thing. Accounting. Well, this first, the dollar sign, I can click on that. That turns into accounting. You'll notice the dollar sign is way over to the left. It's not currency, it's accounting, a little bit different. Phone number. Now, there's a couple ways I can get to it. To format a phone number. One is I can right click, come down to Format Cells. When this comes up, I can click on Special, and there is a phone number. And you'll notice when I put that in there, this kind of tells you what it's going to look like. Give you a preview. That's the format of the phone number. Social Security number, I can right click, or as an alternative, I can come up here to where the format is. Click on that, go down to more number formats. I'll get the same dialog box wherein I can find special formatted as that. If I double click social security number, I will give it, or I can click on it and click OK. Time, I'm going to turn that to time. Fraction, scientific notation, and there we go. All of those are formatted appropriately. Let's look at a few things over here. Here we want to sum a bunch of numbers. Just for shorts, as a shortcut, I'm going to copy this. And then I'll paste it right here. And when I put that in there, you'll see all of the arrays, all of that the formula is asking for are in here. With sum, if you put a bunch of commas in there, you can have as many inputs as you want. I'll just add them all together. Next instruction, rename F2 to F8 as first. So I'll come in here. If I want to rename them, once I have them selected, right up here, the upper left-hand corner, I can rename things. And so I will rename this to first. And when you're naming column vectors or row vectors or any set of cells like that, any type of an array, make sure you use a name that makes sense to you so you can recall it later. And it can be really handy for trying to recall things later. I think I wanted to name this one fifth. Now that I have these, actually, if I want to do something like multiply these together, let's compute first times fifth. And you'll notice when I'm doing this, you'll see that where it's blue and red, those are highlighted. And what that gives me, this first value is the first number in first times the first number in fifth. The next one, so 16 times 3 is 48. The next one is 15 times 18 is 270. 18 times 41 is 738. If you want to do that kind of a calculation, you can do multiplication, which we did, or summation. There's a lot of things that you can do. That's just one of them. Next one, let's conditional format cells that are greater than 50. I'm going to select all these cells, highlight cell rules. So that I can add a new rule, manage rules, or I can come up to highlight cell rules. So we want greater than. And actually, Let's make this a little bit better. I'm going to click on this cell right here. What is that? M8? Yeah. And then I'll show you how this is handy. There's some options of how to fill it. Well, sure, let's go with that value. Click OK. And so M8, let's put in 50. And you can put in whatever number you want. But now all of the cells that are greater than 50 have that type of format applied. I put in 5 or whatever number I want. It's a really quick way to do some very quick analysis to see if you whatever kind of formatting or whatever kind of condition you want to look for, you can have it pop out immediately. Let's add data bars or another type of format. You can have all sorts of formats at the same time. Sure, data bars look good. So there are some additional formats. Okay, let's look at merging cells. When you are confronted with a dilemma, think celestial. And so I'm going to merge them. And there's a couple ways you can merge. One is if you right click, there should be somewhere here that says merge cells. Format insert to the content. Oh, maybe there isn't. So there are, but I know what I usually do though when I merge cells is right up here. It says merge cells. Just click on it. And it says, are you sure you don't want to keep the upper left-hand value? Yes. When you do that, you lose everything but what was in the first cell. Then if I want to unmerge it, come back up here and unmerge cells. And we've lost everything else but that first bit. Okay, there's some merging. Let's look at what happens when we anchor. I'm going to toggle control, the little tilde thing. Let's just see what the formulas are. You'll notice these cells right here, I'll highlight them. They just have numbers. These cells down here, what is that? In column B, so 7, 10, 13, 16, all of these have formulas. And these formulas are a little bit different. The first formula that I have is, let's see, one, if I copy this formula, actually it's just a reference cell. It says equals B2. It's not anchored with anything. There's no dollar signs. But what that means is return what's 5 numbers ahead of that. So if I copy this, I paste it, 5 above that cell is 2, 5 above this cell is 7, that one's 6. And so that just has the reference cell, which is useful. Let's look at what happens when if we inspect the contents of B10. You'll notice that there's a dollar sign in front of the 2. That means the row 2 is anchored. So if I were to copy this cell over, there's 1, 2, 3, but because those are different columns not anchored, but the rows are. So if I copy these down, you'll notice that as I go down, it still has the contents of row 2. If I keep copying it down, it would still just be that row. It basically locks that row, or it anchors it in. If we look at this cell right here, what is that, B13? The column is anchored, but the row is not, which means that the row can change, but the column will not. So if I copy this down, that's a different row. That's 6. If I were to keep going down, it would just keep going down with a reference to that row. But the column is anchored, so as I move over to the right, it's still fixated onto column B. This last one has both the column and the row anchored. That's what those $2 signs are. So no matter where I copy this, it will always be the same value of 1, or actually whatever the content's on here. I mean, I could change this to something else. These are all references, so it's all 100 or whatever the contents of that cell are. There's a little bit about anchoring. Let's look at logic. So the type of fallacy we talked about in this class: appeal to emotion, alternative explanation, improper generalization, personal attack. And I have in here an example. Alexander saw a neighbor drive through a red light. Alexander knows that his neighbor is a member of the church. He concludes that all members of the church are not law-abiding citizens. So what happened here? What kind of fallacy is that? That would be an improper generalization. Sample point of 1 usually is not a very good description of population as a whole. So seeing somebody break a law on one thing doesn't mean everybody of that group of people are going to have a similar response. Which of the following scenarios make the following conditional statements false? If the shoe fits, then wear it. Remember, the principle here is you evaluate the proposition. If the proposition is false, you assume it to be true. Otherwise, if it's true, then you look at what the response is. And if that is true, it's true. If it's false, then the whole thing is false. So the only way it can be false is if the first part is true, the second part is false. So if we have the examples, Kim and Diego, the shoe does not fit. Therefore, just assume the whole thing's true and move on. Baby Mandy has never worn shoes. Well, that's the first part's not true. We'll skip it. Beth is careful to make sure her running shoes fit before she wears them in the marathon. It's a great idea. Let's see if the shoe fits. It does, and then she wears it. True. That means the whole conditional statement is true. Look what happened to Sam. The red shoe fits on Sam's foot, but Sam only wears black shoes. So the shoe fits. It does, but then he doesn't wear it. Therefore, the whole conditional statement is false. Let's look at what the propositions are. If I study, I will do well. A proposition is something that you can use as a hypothesis. You can test to see if it's true or false. Yes, you can study, you can evaluate if that's true or not. If I sleep 7 hours a day, I can concentrate better. That's another thing that you can see if it's true or false. You need to study for your exam. That's a mandated statement. So that's not a proposition. You can't really test that. Why should I go there? It's a question. It's not something you can test either. Which of these are conditional statements? If it snows, then I will eat ice cream. That is a conditional statement. If you have an if and a then, it's a conditional statement. That's an explicit conditional statement. This next one's an implicit one. Every time he bikes to work, he forgets his lunch. And so the if part is if he bikes to work, then part is he forgets his lunch. Last one is a shoe. Oh, okay, but there's no then. There's the if part. You can test if something's a shoe or not, but you can't test what happens when it is a shoe. Therefore, that's not a conditional statement. Let's take a look at some functions. I should make these larger, shouldn't I? So we have Teola's grades for the semester. She wants to know what the minimum score she needs on her final exam to maintain an A that's 93% or higher. Not an A minus, but an A. She has a bunch of grades on here. There's some formulas we can use. One is we can do equals this times this. And that gives us a value here. And then we can sum these together. And that gives you a grade. Yeah, another way you can do it is this times this plus that times that. Let's see if I'm doing it right. That's a lot of work, but it gets you there. Probably the easiest way to do it is a sum product formula. If I type it right. So we have, which is what we did with the first one. All of those are the same thing. Actually, let's give it some more detail. Okay. And the question is, what does she need on her final exam? If she skips the final exam completely, the best she can do is a 73.8. That's a C. It's not really what she wants, especially with all the work that she's been getting, all the hard work effort she's been putting in. We can throw in some numbers, put in 90%. If she gets a 90 on her final, that means she has a 91.8%. That's pretty good. That's an A minus, still in the A range. I think she wants to do a little bit better. You can keep plugging in numbers. You'll see they go up. No. 94. Oh, that's close. 95. There you go. 96 will get her exactly 93%. But of course, she can do better. And she'll still maintain that A. Okay, so there's her final grade. Let's look at using a sort function. We have this data that's sorted by size. number of poultry production in metric tons, but we want to have it sorted by year. There's two formulas you can do. One is sort, and then you select the data, the sort index. We want to index, I mean, which column we want to sort it by. Let's do it by the first column. The sort order is either 1 ascending or 2 descending. I can click on it. I can just type it out. If I'm lazy, I don't want to add the last parenthesis, I'll just hit enter. It'll take. So that's one way to sort it using the sort formula. You can also do sort by. That takes the array initially. And then the first column you want to sort it by, let's do year. I'll select the year in 1. And it'll do the same thing. The sort by formula is handy if you want to sort by multiple columns. If you're only sorting by 1, it might be easier just to use a sort formula. Let's look at a few things over here. Paycheck is 534.45. How much is tithing? 534.45. Tithing is 10% of that amount. That's one way to do it. The other way we can do it is equals 0.1 times that. 0.1 and 10% are the same thing. So that's why you'll get the same answer either way you do it. You purchase an item for $65.81, get a 15% discount. How much is the discount? The discount is 65.81 times 15%. So $9.87 is what the discount is. What do you pay? Two ways to do it. You put in the amount minus the discount. And that gets us where we need. The other way we can do it is 100% minus 15% times 65 points times the amount of the purchase. And there you go. Well, I said 100%, but if you want to do a few less keystrokes, remember that 100% is the same thing as 1. Or if you want to, I don't know, you can mix up however you want. You could put in 0.15, and either way, you'll get to the same thing. Okay, we have a statement here. How many characters long is this above statement? When you're confronted with a dilemma, think celestial. We use a formula called len. 56. Evaluate f of 5 equals 65 divided by x. So the f part, that's the name of the function. 5 are the inputs. We only have one input in here. 65, and then the statement we're evaluating is 65 divided by x. So 65 divided by 5 when x equals 5. I mean, really what I could do, I could call that one x. Actually, let's rename it. I'm going to come up here to this part. I will name this x. That's so, and so now I can say equals 65 divided by x. And the handy part about this is if I want to start putting different numbers in here or whatever it is, you know, that I can evaluate different values of x. Here's a formula with a few inputs. Thought this might be interesting. The formula to determine how far a vehicle will travel while braking is 1/2 times initial velocity times the time required to stop. If you're traveling 88 miles an hour, if it takes 4.4 seconds to stop, how far will the car travel before it stops completely? So let's use that formula. 0.5 times 88 times 4.4. And I need to put an equal sign so it knows what's in the formula. It's going to take almost 200 feet to be able to stop. Now that's once you start stopping. That does not include the reaction time, which you might want to build in. Okay, so there is some functions. Let's go to this very last worksheet. I downloaded some data for poultry production in metric tons for a bunch of countries. And what might make it a little bit easier, I'm going to rename these arrays. So I picked all of Tonga, and I will call that Tonga, which I rename right up here in the upper corner. So Tonga. And then let's do the same thing for Samoa. Papua New Guinea, I don't know if you can name it with a space in there. I'll just call it PNG. Cook Islands has a space, so I'll just call that Cook. Name it something that you could remember. Fiji is nice. There's only a few letters in there. So I shall call that Fiji. Australia, I will call that AUS, as long as I remember what I named those. But it makes sense to use something easy. Now I want to compute the average for each of these. Average. Tonga, average. Samoa, average. PNG, average. Cook, average. Fiji, average. AUS. Okay, I'm going to format these just so they look a little nicer. There we go. And so if I want to do the standard deviation, it's a lot of work to type all that, and I already did. Let me take a shortcut. So the cell references, by renaming those cells, I created some basically some anchored references. If they were not anchored and I copied them over to the next one, that would not be what I want. But they're anchored. I'm gonna copy these. I'll paste them in here. Notice we still have the average values. But what I can do when I can select these cells which have these formulas in here. The formulas are equals average in the country. So I'm going to hit Control 8, and that will do replace. There's a couple of ways to get to this replace part. But among the cells that I have selected, I am going to find every time it says average. Let's see. I think that's the right formula. And then I'll replace that with standard deviation formula. Replace all. Oh, it worked. Now, those cells that are selected will give me the standard deviation for each of those. Okay, and so let's do something different. Well, let's look at the difference from the mean. Equals, oh, I'll just do different from the mean instead of the percent, whatever. So average, and I want AUS minus that. And so actually, why don't I do this? S2 minus. So that is 487,000 below what the average is. And then those are, oh, I think I like numbers with negatives instead of accounting. There you go. One decimal should be fine. So let's see. There we go. Or, well, make them red or whatever. However you want to format these. So these are, I like negative numbers. So here you can see how the differences are from the average. It looks like there had been a lot of growth in here. Actually, if we were to graph this out, I'm just going to pop this in a graph. Time series or line graph might be good. Oh yeah, we can see a bunch of growth in here. Might be years. And so naturally, if the average is, let's see, what is that? 537, right around here. About right here. So yeah, of course, you'll have a huge gap between here, and then you'll have that type of a gap between those. All right. Well, I hope this was useful in reviewing some of the concepts that we've gone over this past little bit.